been reading so hard. Now, if you see it now, the UI students now, they have time to rest. They can decide to do whatever they like. And before UI resume, maybe it's next year, February. So they have August, September, October, November, December, January, February. So they have 7 good months to do whatever they want to do. So that's why you have to read at the appropriate time. So anybody that failed UI now, is either the person is still crying, or the person is waiting for another school, or the person is waiting for next year. And that person might not have been reading, not disputing the fact that some people read, they did their best, but they still failed. That's part of life. That one is normal. People read and fail. So, but I'm talking about people that were not even serious at all. So, if you have not been serious, you're only postponing your punishment. So, anybody that fails now, especially OAU, is still next year, 2027. And 2027, you don't know what will happen. There is election. There are a lot of things that will happen. And the funniest thing, because all the, out of 20-something thousand that registered for UI, they are picking just 4,000 plus, which means 15,000 plus expects at least 10,000 of those people to come and register for OAU. And there are a lot of them that scored above 300 that they failed UI already. And when those ones are coming back to AU, they will come with vengeance. They will come with, they failed UI. They must not fail AU. So which means that your own competition has quadrupled compared to what you had before. So please, if you have not been working or reading so hard, don't let anybody beg you. Read. At the end of the day, you saw the way all of them were happy yesterday. But go and ask them, it's not the journey of a day. Some of them, when I called them yesterday, even I myself, when I saw the results, I was really happy for them. So, because it's not the journey of a day, it's a journey of 1,000 miles. What do you think Samuel will feel? What will Ife feel? What will Wura, Sheun, and Co? What will they feel? You know how long they have been on it. You know how long. And those people, imagine Samuel scoring 330 something last year, no admission. But he said he wanted medicine, and he had to go again. Now getting the medicine on a platter of gold. I think it's 87 point something. Now, cut off for UI last year was 78. So imagine someone beating medicine cut off with almost like 9 marks. That's medicine. And that's the highest cut off you can ever have. So that's the journey of life. There are challenges, but the thing is that we just have different challenges at different points. Everybody has his own challenges. I always tell you, a lot of things can be your challenges. Either your background, if you're not so strong before, it's not a problem. You just need to keep working. Maybe you were not strong at all. A stage is coming that you will get there. Thank God you know Mary. Look at Mary now. I was so happy when I saw Mary at 85. Mary wrote last year. She wrote 2 years ago. She wanted medicine. So that's just life. But I know on Sunday now, I won't dance. Our own dancing steps will be different. It will be different. But those days of, if she wants to dance, they should allow her to dance. If she wants to roll on the floor. Because there were times that she has been crying alone. She will just look at her result and she will start crying. God. But one thing is that success is always once. Now that she has it now, there's progress. And that thing that she has overcome now, one thing I know is that her children will not suffer it. If she has a way, if she marries a good husband, her children will not suffer. So, journey of life comes in different forms. So please, maybe your jam was not strong enough and you are still fighting for something better. Shall fight. Give it everything. Then if it comes, Alhamdulillah. If it did not come, Alhamdulillah. God will still take glory. But I pray your own will come this time. Is that taken? Please. And one of the major problems students can have is their parents. I always say something that the moment your parents support your journey, you have achieved it. Just forget everything. The moment you are serious with your life and your parents now support you, you failed once, your parents say, don't worry, keep fighting. You failed the second time, your parents still say, I'm behind you. You failed the third time, and your parents still say, don't worry, everything will be fine. You are the luckiest person on earth. You are the luckiest person. Wura could have left last year. I remember when she was crying. She said she's not writing JAMB again. Her mommy called her, she should be coming home, that she's not going to do anything for her again. Her daddy said she's not going to do it, they are not going to do anything. He started crying that I said, this is your last chance. It's not like you didn't do well. You did well, but you messed up. And best is pick yourself up. I was the one that drove Samuel to Ife. When I was coming, I told him, I gave him 4 options. One is that OAU has done what they will do. What do we do next? Will you accept any course they give you? Will you go and change to another school? Will you join JAMB class again? It was a very difficult decision. And he said he wants this school, that I cannot go to another school, that he would rather write JAMB again. But I could remember when he came to JAMB class, he was looking so sad. Like, how will I start again? But look at Samuel now. Samuel will be like, if you see him outside now, you will not know he has written JAMB maybe 2-3 times. You will not know. That's one thing about success. The moment it comes, it will be as if you have never passed through problem before. That's just one thing. If you see Mary now, it's only if Mary tells someone that I wrote JAMB 2-3 times. That's when they will know. But anybody that sees her now will say, Dr. Mary, that's what they will be saying. Dr. Mary, that's what they will say. But people that have given up before her, those ones might still be facing life challenges. And if you don't face your challenges now, you will face it later. Everybody. I also wrote down, me, I cannot even count again. But before admission, I wrote down 3 times. Before admission, WAEC and Logunju. That's be 2005, but in WAEC, the 2011. If I gain admission in 2011. So, journey of life. But thank God for how far things have been going on now. So please, if you have done well in your JAMB, fine. Prepare so hard for your post-UTME. And whatever you want to study, work so hard for it. If you did not do well, it's fine. Whatever you want to study, work hard for it. If it comes, embrace it. If it doesn't, because sometimes we just pray, all of you will pass in Jesus' name. Everybody will shout at the loudest of their voice, amen. But the sincere truth is that out of everybody that wrote UI, do you think that many of them that failed did not pray? Do you think they did not pray? Many of them prayed. Even ọjọ́ tí wọ́n wá pray for one, you will see that ó lè já wọn gan náà jọra mọ́lẹ̀ jù. They prayed. But God always also wants process. Because those are the things that will make you. God is also God of order, processes. Is that taken? So there's always a process to everything. You can gain admission on merit now and your first JAMB, and you get to university and they send you out. You can gain it on second time. I have a friend, I was seeing a friend on Facebook which day. She first gained botany. After like some years, she left. She could not cope. She had to go and do nursing properly. She's abroad with her family now, doing very fine. So please, work hard. Don't give up on yourself, especially if you have a very wrong background. Don't give up on yourself. And don't think that you cannot know it. Don't think that you don't have brain. When you are reading it, it might be difficult. It might look tough when you are reading it. Yes, but the most important thing is that keep working. Keep meeting with people. Let them teach you. Just be strategic and be wise. God will help you. So you sent some topics in chemistry that we should do. If you how many times did you write down? 3 times. If you know that your SS3 to do anything to take jam. So can you see? That's the journey. I know some of you have already written 3 times. Abby, how many of you have written 3 times already? This is the 3rd time. Don't worry, it's settled already. It's settled. And those of you that have written just once, it is that once you will use to make it. Is that taken? So don't give up. So you sent some topics for chemistry. I don't know. I don't think chemistry should really be a problem, but I know OAU chemistry at times is one of. So the topics you listed, Ozonolysis, redox reaction. All of you should know ozonolysis. Is there anybody that does not know ozonolysis here? If you are online, you can comment too if you don't know when I ask. And please don't be shy. Oh. If I say, do you know? And you are keeping quiet so that people will not feel like you don't know. All these things now that you listed here, they are not even things that should take us 1 hour. So don't be shy. If you don't know it, let me know. I'm just working with what you listed. But one of the parts that you might have issues with OAU is organic chemistry. But last year, chemistry was not tough. It was not compared to what they used to set before. It was just normal chemistry. Physics was just normal. Everything was normal. They didn't set all this advanced. How many of you have those OOU? I mean, all those series? Small, one-time success. Anat, you don't have it. Not yet. Not Anat, the way to put it back there, front and back. Not yet. Yeah. Who is calling? Oh, time of play like. Cut there. Because to be, I've made arrangements for you already. Even if I know there are questions you will see, if you are written UI and you did well, you can pass OAU this time. It's no OAU just bring technicality. They just bring some things that you have to think about it, then do it. That's the thing. Last year, many of you would have seen last year questions. Abi, you will see that last year, if you compare last year to the previous years used to be advanced, and those are the parts where you see all this ozonolysis, dry distillation, all those organic chemistry that you might not see in normal Ababio, which I'll quickly teach you those ones now. That's before. But if you know chemistry, you know physics, you know biology to some extent, based on what they said last year, and you can reason, you will pass away. You will pass. The only thing that I know might just be technical is aptitude. But aside the fact that you have to prepare for the worst. Either they bring the complex ones or they bring the simple ones you want to pass. Do you get my point? So that's why you still have to practice the one-time success too. All those questions, I can see one there. Please let me to pass it. That's physics, yes. That's chemistry. Let me to pass it because of people online. So if you have these books, there are like 8 of them. There are 2 of physics, 2 of chemistry, 1 of biology. The questions there might look tough, but at least for practicing, they are not tough. For practicing, you can. I just wish, even me, I have exams soon. And this place I am is not even where you joke. You can't be in medicine and still be going through some things. But I just have to look for time to sacrifice. And even during jam classes, I'll still come and teach. I just pray that God will help me to align my ways. That's the most important thing. Well, please, as much as possible, practice one-time success too. So let me list what you said one by one, then I'll quickly explain it. All the organic, then generally basic organic. Even if, at least to those of you that attended jam class here, I'm not saying those that just joined us. To those of you that attended jam class here, basic organic you should know. Like the normal organic chemistry, Ababio organic chemistry, Ababio inorganic, what they can ask you in jam, all those things you should know. But if you feel like you don't know those ones, I think we have a long way to go. You have a long way to go. But that's not a problem. So, ozonolysis. Generally, if you are studying organic chemistry, in OAU you might be lucky. Your 10 questions might be organic. You might be lucky, it might be organic, it might be physical, but there's nothing hard. You see all these acid, base, and salt, and determine Bronsted, Lowry, and this one, what's it called? Conjugate base, conjugate acid, All those are the kind of things. Chemical bonding. Know your chemical bonding well. No acid base and salts well. No chemical kinetics well. All those are topics in inorganic that they can ask you in normal physical chemistry. For inorganic, mostly, they can just help you to ask for tests for metals and tests for gases. Those are the likely things they can ask you for inorganic. And for organic, that's where the net is. So I will just teach you those things you listed. But is there anybody that has issue with ozonolysis? And if you have any issue with any topic, please, you can comment online too, so that we'll deal with it. Then for redox reaction, but let me, now, before I talk about ozonolysis, these are the things you must have known in chemistry. Ozonolysis is not hard. It's even the simplest. But first is, you must know the introduction to organic chemistry. That introduction, you must know what is organic compound, homologous series, normal characteristics of organic compounds, how many bonds can carbon form, all those normal things, how many bonds can oxygen form, all those introduction. Then the next thing you must know is how to name compound. I want to believe all of us can name organic compounds here. You must know how to name compounds. Those ones are the normal things. Then after that, you must know isomerisms. All the types of isomerism. I think one of you also said here that you want to know about tautomerism. I don't know if they will ask you a question on that, but I will show you what tautomerism means. It's under isomerism too. But when you are talking about some of the reactions of alkyne, you will see tautomerism. All of this should not be your problem by now. By now, if you are writing away, I know some of you, boye journey pass exam like a journey wole. It's not like you are groomed properly, but majority of you that I know here that started jam class with us should know all these things. Then the next thing, general physical properties. There are a lot of questions they can ask you here. So the general physical properties of organic compounds. Then general chemical properties. I will see one or two things they might ask you here, and I'll quickly talk about them. Then after that, you now pick them one by one. Alkanes. There is nothing much on alkanes that they can ask you, except this Clemenson and Wolff-Kirchner's reduction that they can still ask you. Some of you wrote it here that you don't know. Then alkenes. Alkenes is when you are studying alkenes that you now talk about ozonolysis. Ozonolysis is one of the reactions of alkene. Is one of the reactions of alkenes. Alkene undergoes several reactions. Addition reaction, hydration reaction, addition reaction, hydration reaction, hydrogenation. All this addition is generally where you have hydrogenation. All of you know this, dehydrogenation, dehydro or hydrogen. Okay, I already said hydrogenation. You can also have the hydrogenation as part of the reaction. That one will now be elimination. The hydrogenation will be elimination. Hydrogenation will be addition. Then you will have what's it called? Hydrohalogenation. Hydrohalogenation. That's when you start talking about Markovnikov. So this is an aspect where you can ask me questions. Hydrogenation and hydration. If you use in a question, Lily, because you have to apply Markovnikov's rule here. You have to apply Markovnikov's rule, and you have to apply Cezeff's rule. So these two rules are applied here. So when you can ask you. Then, after you know this, then you can talk about ozonolysis too. All of us know alkene. Alkenes have double bonds, So when you are talking about ozonolysis, you are just talking about splitting of that double bond. So when you split the double bond, you will now form carbonyl compounds. Is there anybody that does not know any of these reactions? I don't know if anybody is talking about Markovnikov's rule here. So now, I'm still going to come back to this. Now, let me take it from simplicity. This is what now? I don't have to be putting hydrogen there. I don't even have to put all the bonds. If I just put this, you should know what I'm saying by now. Which compound is that? 18, Abi. So for this 18 now, you will just do it like this. Just break it apart and add oxygen. That's ozonolysis. Meaning that ozone, you will add ozone in the presence of dimethyl sulfide or zinc in CH3, COOH. Any of these, because where you can ask you for the catalyst, they can ask you for all of these things. So now, if you add, this is 18. So in ozonolysis, ozone is this guy. You are using ozone to split this guy. You know lysis means what? Splitting, Abi. So ozonolysis means splitting by ozone. So this 18 now, they will now ask you that if 18 undergoes ozonolysis, what are the products you will get? Then you will now say that, you know I've splitted it, Abi. Then I will have C double bond O plus O double bond C. What did I do there? I splitted the bond, added oxygen here, added oxygen here, Abi. Now, if you look at what's the name of this compound? Adeshewa, Ademide, Maranju, Epo, Molebi, gbogbo yin questions. What's the name of this compound? Methanol. I can't hear you. So yeah. You know, when you get to a stage, if you are preparing for some exams, especially OAU in particular, OAU students they are mad though. OAU students are not ordinary students though. Like, their brain is always working. I'm not joking now. I'm not trying to hype OAU. You that you want to prepare for AU, you work God or mad. I don't know if you are getting. OAU students don't joke with some things. Like, you must be ready. So if they immediately you look at something, if you cannot say it straight, oh, show OAU student, you will have to work and get there. Ikma. Ikma, what compound is this? Methanol. How many carbon do we have? That's why I said, as I know you student, I don't have to start adding HH for you. How many bonds can carbon form? 4. You should know that. So if I have 2 here, how many is left? Those 2, what would they bond with? Hydrogen. So which means that there must be hydrogen here, there must be hydrogen here. So this bond is complete. Oxygen can form 2 bonds. Carbon can form 4 bonds. Hydrogen will form one bond. And now this is what? Methanol. So what would this one be? Methanol. I know some of you can say something else. It's still methanol. Yes. I will explain it. But I want to explain what someone asked. Let's just speak it one by one. So one of the problems you can have is that if you cannot name, you don't know how to name, then that's the only problem you can have. But anybody preparing for you, there's always a stage that we get to in preparation that immediately I'm throwing, my students are on that matter for me. Immediately. That's when you know that you are ready. I used to take all my students to AU. I'm at Debe, I'm at Lush exam. And when we get to the hall, we used to go overnight. We'll sit down. By the time I start throwing questions, you see, sometimes I'll just say, everybody go and sleep. You have passed. That's how the preparation used to be. So now, this is also methanol. So if I ask you that, if I now tell you that what are the products you are going to get, or what is the product you are going to get, or ozonolysis of 18, you will get methanol as your answer. And what did I do? Splitted the bond, Abi, and I had 2 compounds. The 2 compounds are the same because of the same number of carbon. Everybody, what will I have now if I have? What will be my product on ozonolysis? The moment you look at it, sometimes you don't have to even write. The moment you look at, I'm not telling you not to write now, you're all learning, but there are some of you here that, as I'm speaking, and the way I'm speaking, I don't want you to be intimidated. I'm just preparing your mind. That's what it is. So, and as much as possible, you can write. Even if you are learning it slow, shall be learning. Is that taking? But there are some of you here that should be getting what I'm saying straight. And nobody of my sing sorry one because one later didn't because of me one miss the question by it should be bonus to them. So what would be my product here? Exactly. Mitana and Itana. What do? Just split it. Abi, when you split it, you have C double bond O, that's Mitana, Abi, plus, this is double bond OCC. Then you already know that's Itana because it is H that will be here. Don't make mistake and say Itanone. There's nothing like Itanone. Acanone starts from propanone. Is that taking? So just put your H if you are confused. Put it. But don't make mistake and be saying Timbawa and Bito Tishi cover the 14 Latin. Cobalt 1, 2, 3, 4, 5. Carbon should not form more than what? More than 4. Is that taking? So that's what you now in this case now this is Mitana and this is what? Itana. That's what you have. So this is a question where you can ask you. But let's make it where you can now come in reverse. They can say that between which alkene will give you Mitana and Itana. What do? Just join them back. Abi, which alkene will give you Mitana and Itana? What do? You join them back. That means which alkene? Propene. Do you get that? Is that just remove the oxygen and join them back. So they can go like this, they can go like this. Are you fine? What's your name? Tea. And I say you like tea and bread. Zainab, are you fine? Please be active. Is that taken? Oh yeah, everybody quickly. What will be this product? Ozonolysis. Which compound is this? If you cannot name compound, it's ready for organic chemistry. So this is what? 2-methyl Abi. This is 2-methyl propane. You must know that. But in case they ask you in reverse, that's what you will pick as your answer. But now, what will be your product? Propanone and Mitana. She gets. Be sharp. So that means we're going to have 1, 2, then double bond O, Abi. Then put the C. Then plus double bond O, then put the C. So that is what? Propanone, and what? Mitana. Those are your products. So if they now ask you that if you join propanone and Mitana together, what will you get? You will get 2-methyl propane. Do you get? So that's it. You can have a ring too, but if you have a ring, I'm just saying, if you have a ring and they say that what was ozonolysis of this guy give you, same thing. The way you broke the ring, broke it here, just break it. It's already like a ring, but when you break it, it will turn to a straight chain. That means we're going to have something like this. O, Abi, then there's carbon, carbon, carbon. Then you continue to count 4 carbon. Then O again. What did we do? It was like this. C, C, double bond, C, single bond, C. That's what we have, Abi. So now, if I split it, what happened? Okonshini. So it didn't give 2 products, Abi. So you have 1, 2, 3, 4, Abi. So you have 1, 4, and that's both 1, 4. That's Akanabi. Eh? Eh? I don't want to say dia, but they are the same compound, but you can just, I don't want to say both. If you say butana, then it will just be one. So you can still say 1,4-di. The dia is sounding weird, but which should be correct? Is that taken? Like 2, but you know there is the first one, 1 and 4, abi. So, but you will know when you see it in the option. I'm just saying, but that should be correct. Is that taken? So the next one, let's leave. So for the sake of those that say Marconi's rule and say Z's rule, this one now, before you can talk about Marconi's rule, say Z's rule, you must also know some things. There's what we call inductive effects. Inductive effects. Even if you don't know anything for OAU exam, you should know inductive effects. There's what we call inductive effect. There's what we call mesomeric effects. There's what we call steric effects. There are a lot of them. But for OAU's sake, all these things, they will not ask you directly. They help you to determine some things. They can ask you to determine the acidity of a compound. That means which one is more acidic, which one is less acidic. So they can ask you to determine the basicity or the acidity of a compound. When you have the experience of these guys, you'll be able to answer this. Now, when you have the experience of these guys, you will know what CZ3 is talking about. They are all related. But let's talk about Marconi's rule and CZ rule. Everybody should know Marconi's rule. Marconi's rule is the normal rule for Ababio. Abi? But let's say you don't know because of the person that asked. So please, on alkene, I will just do these 2 examples now. These 2. So that we use them to explain this. After that, I move on to the next thing. Please, do you know about ozonolysis now? Anytime they ask you that, what is ozonolysis? It is the splitting of alkene to give carbonyl compounds. Splitting of alkene to give carbonyl compounds. So the carbonyl compound can be a mixture of alkanone and alkanal, and you can reverse it. That's it. So, yeah, let's talk about it. For this one, don't let us waste time too. Hydrohalogenation means you are adding hydrogen and what? Halogen. It can be any halogen. You want to add hydrogen and halogen to alkene, but there is a way you do it. You can follow Marconi's rule, but if your question says don't follow Marconi's rule, then you will follow what we call anti-Marconi's rule. And if they now say, what is your major product? Then you will know your major product by knowing the effect or CZ's rule. Who is that? So now, let's look at it. For hydrohalogenation. So let's take an alkene, and let me just do it once. We have 1, 2, 3, 4 double bond. That's an alkene. All of us can name this compound, Abi. What's the name of the compound? 2-methyl. Now, 2-methyl-butene. Now, you're adding hydrogen. That's another thing you need to know here. If you're adding hydrogen halide, this hydrogen halide can be this, H+, Cl-. H+ is usually called what as a reagent. When you are undergoing organic reactions, this is a common question where you also ask. When you are undergoing organic reaction, there's what we call homolytic fission. Homolytic fission and heterolytic fission. Let me quickly explain this before I move on with that. Reagents that I want to add to my organic compound. This is a reagent. I want to add it to this guy. But before this guy will be added to this guy, it will split apart. It will give me H plus and what? And Cl minus. Now, this type of splitting is what we call heterolytic fission. The type of breaking or splitting of compound to give ions. Then we call it heterolytic fission. Now, this one leads to heterolytic fission is the splitting that leads to formation of ions. While homolytic fission is the splitting that leads to formation of radicals. So when you start solving your past questions, you will see them. Now, for heterolytic fission, we have two types of technically ions, but I will not leave it as ions. You can call it electrophiles. And you also have what we call nucleophiles. Is that taken? Now, anytime you have, let's look at this compound. Let me give you an example of homolytic fission. Now, look at the difference, everybody. Do you know this reaction in alkane, substitution reaction? Do you remember? Do you remember this substitution reaction where chlorine will react with alkane to give first product, second product, third product, fourth product? Normal jump now. So now, that chlorine, you remember that if you take methane, you first react it with chlorine, then it will remove first hydrogen, remove second hydrogen. This chlorine here, you will notice something. It's a reagent that will be added to this guy. But what will it undergo? It will undergo what we call homolytic fission. First, if you understand the mechanism. Shebi, you people have been doing chemistry. Have you talked about this substitution? Did you talk about the mechanism? How all those things happen? Now, for the radicals, we are going to, because when you ask you questions here, so that's why you have to know some things. That's why when you questions still goes beyond above you. Now, for one thing, you remember this reaction. What does this reaction require? Sunlight. It requires ultraviolet ray. Abi, what would this light do? It will split this guy. Akoko breakers, imeji. You remember this is a bond between them. A bond represents two electrons. Do you agree? So now, if these guys have two electrons between them, when they are joined together, one electron will go to this guy, one electron will go to this guy. Now, if two electrons goes to one, then one will be positive, one will be negative. But one electron goes to this guy, one electron goes to this guy. Now, the electron that goes to this guy make this one to become Cl dot. That's the electron. Then plus another Cl dot. That's the second one. Now, this one will now start breaking something, and the reaction will continue. That's another story. But from what we have here, these guys, we call them radicals. So when they equally share their electrons, we call them radicals. But when you just have one electron in an atom, we call it radical. Look at the difference here. In this case, just like this reaction, HCl wants to react with this guy. Here, what wants to react? Chlorine, Abi. Here, HCl. But you notice something. This HCl, there's an electron between them, Abi, that they are both sharing. You know how they form bond. They are sharing electron. But one thing you will notice is that between hydrogen and chlorine, which one is more electronegative? Chlorine. And what does that mean? Chlorine will pull electron towards itself more, Abi. So these two electrons will be gained by chlorine. In this place now, they both have equal strength. So give me one, take one. That's how they did it. But here now, chlorine has higher strength than hydrogen. So chlorine will take the 2 electrons. Abi, by the time it takes the 2 electrons, when an atom loses electron, what will it carry? Positive charge. Hydrogen becomes positive. What will this one carry? Negative. You understand that? Now, in a type of splitting in which you produce ions, not radicals now, then we call it what? Heterolytic fission. So they can ask you, heterolytic fission always leads to formation of A, radicals, B, ions, C, you get that point. So heterolytic fission will lead to formation of radicals. But now, this, will lead to formation of ions. Now, these ions you have here, they now have names. All positive ions are usually called electrophiles, which means heterolytic fission can lead to formation of electrophiles. Then what is now the difference between electrophiles and nucleophiles? Do we all know that? One problem can lead to another, because all of these things, they are general knowledge. Do we all know what electrophiles are? Thank God. They are nucleophiles. So, negatives are what? Nucleophiles. Positive are electrophile. Between Lewis base and Lewis acid, which one is an electrophile? Lewis acid. Is that taken? You must think about everything. So, yes. To determine the stability. Rank the stability. Yes, but the COE will never ask you that. COE will not ask you to start arranging the radicals in order of stability. Is that taken? It has never been in their question before. So, from what we have here, you now have, can we go back to this now? So we want to add hydrogen and chlorine to this guy. Then when we are adding hydrogen and chlorine, if there's any question on everything I've written, you can ask. So I can this guy and this guy. Let me name this guy and this guy. Let me name number the 1, 2, 3, 4. Which carbon is carrying more hydrogen? Carbon 2. Abi? Carbon 3 is carrying carbon. So it can't form anything again. Let's make 4 bonds at 1, 2, 3, 4. That's complete. So now, meaning that carbon 2 has hydrogen here, normally. So if you're adding HCl to this guy, where will the hydrogen go? It will go to carbon 2, Abi. That means the carbon that has higher hydrogen. Where will the chlorine go? It will go to carbon 3, Abi. So that means your product will be, you can have 2 possible products. The first one is this, CCH, that's the hydrogen, CCCl, and you can also have this product, CCCl, CCC. In the first case, which one obeys Marconi's rule? 1 and 2. Which one obeys Marconi's rule? 1. The hydrogen goes to the carbon that has higher hydrogen, while the chlorine or the halogen goes to the carbon that has less hydrogen. But in the second case now, this is called anti-Marconi's. Anti-Marconi's. Why this one obeys Marconi's? Now, you can have another product here, according to let's go on first. Let's go on. We'll talk about one more thing soon. So that, do you understand Marconi's rule now? If they now ask you that which one is your major products, then you can apply CZ rule. Question can say which one is your major products. CZ rule states that the compound with highly substituted at Q around the reaction site. The compound with highly substituted at Q around the reaction site is the one that is stable, and that is your major product. Your major product means which one is more stable out of the two products. Do you get that? Look at this. Look at this guy. Look at, if anything wants to react here. Are you still writing? Just understand those principles. You can learn the rules yourself. You can learn, nobody will ask you definition. You can go and learn about definitions. Just write it somewhere. Then when you are reading, you read the definition and all. So, but understand it is the most important thing. Can we move on? Now, look at this chlorine. Anything that wants to attack this compound will most likely attack chlorine. And if you look at this chlorine, there's a carbon around here. Abi, there's also a carbon around here. Then there are carbons around here. But look at this chlorine. There's a carbon here and there are carbons here. Can you see that? Between these two chlorine, which one do you think is more protected? The first one. Because if you come from the top, there's something to defend. If you come from this side, there's something to defend. There are stories that guide that. That's where steric effect comes in. If you come here, it's easier to attack from here, or attack from here, or even attack from here. But for this one, on three sides, it's protected. So that means that this is your major product. They can ask you, if they don't say major product, they will say which one is most stable, and that is your stable product. Now, let me give you this example. I hope you know the difference between this for now. Let me give you a quick example of this, but we use hydration in this case now. Quickly, give me the product of this guy following Marconi's rule, and tell me your major products. We're adding water this time now. And when you add water, it means H plus and OH minus. So if you follow Marconi's rule, which one will be your major products? I will now use it in reverse. When the reaction go forward, we have hydration. Hydration is not really a reversible reaction. There are some catalysts to use and not. But if you want to produce what you have back, we have what we call dehydration. Hydration of alkene will give you alkanol. Dehydration of alkanol will give you alkene. And you know those ones have conditions. But let's get our products first. What will be the products here? There's a reason I will use this one again for dehydration. So you see 3 things that can happen. Then you now tell me your answer. Let me even add one more carbon here. Oh yeah, do you have your products already? Please, let's not waste time. We still have a lot to do. For the redox reactions, let's shall finish the organic chemistry part first. Then after that, we can talk about the redox reaction. Or we can talk about that reactions if possible. I've not moved on. No. I'll teach you hybridization soon. I will not waste time on that too. Another question they used to ask on that is overlapping orbitals and all of those things. And they can also ask you which one is, they can give you nitrogen and HCl and tell them the type of intermolecular forces that can be present. All those are general. Have you drawn it? So yeah, now what do you have? Hydrogen will go to this carbon. Abi, OH will come to this carbon. Then at the end of the day, you are going to have, but you already know the name of this compound. 1, 2, 3. That's 3-methyl pentsuine. Abi, so them are going to quite a minute to teach. But kò sí nǹkan t'Ọlọ́run ò lè ṣe. Abi, so these are your two products, two likely products. So you're going to have, am I correct? So you're going to have 3-methyl pent 3-ol, Abi, and here you can have 3-methyl pent 2-ol. Are you lost? Then which one is our major product? First one, Shey. God bless you. So you can see that OH, which is the functional group now, is well protected. Abi, so anyone that is well protected, that's just what CZ3 is saying, that is your major product. Anyone that has highly substituted alkyl, you know these are alkyl, Abi, alkyl, ethyl, methyl, ethyl, all those alkyl, they are surrounding the OH, they are protecting it by steric effects. Yeah, now this one too is being protected, but the protection is not as this one. If thief should come now with their guns, give me my OH. If they come through here, these guys are protecting. If they come through here, these guys are protecting. If they come through here. But if thief come here, it might be difficult. But they still have, they can over just one here. And they can also go through this way. They can also go through this way. So this one is easily attacked compared to this one. And that's what CZ3 is saying. Is that taken? So now, let's now do dehydration. Because there are 3 products you can have in that case that is not in your ordinary level exam, in your O level. So if hydration is the addition of water, dehydration will be what? Removal of water. And you remember, what are the catalysts we use for dehydration? H2SO4. Under what condition? Under what temperature condition? High temperature. Oh, it has a value now. 180 degrees or 175 degrees Celsius. Abi? What's it called? H2SO4. Abi? You know there are 2 products you are going to get. If the H2SO4 is not conc, or the temperature is 145, or the alkanoid is in excess. I hope you still remember all those things. Those are normal jam, this thing. Sharp. We don't have time. Can we do dehydration now? But let me show you how dehydration happens. You have already formed your alkanoid. So if there's anybody that does not understand what we are saying online, you can talk so that we'll take it slowly for your sake. But all of these things we are still saying, they are general things you know. I just want to show you 1 or 2 things. Bright. Are you bright? Is it going well? So let's say we have this organic compound. And they ask you that what is your major product? If this guy undergoes dehydration under the conditions of conc H2SO4 at 180, or let me just say 170 to 180 degrees Celsius, Anytime you hear this condition, that means you produce alkene, abi? But if it is at 145 degrees Celsius, you will produce what? Alkoxy alkane. Do you remember? Anat, do you remember? Something so yẹ kó máa gbá lórí by now. Some things are nothing. You know, when you are going for some exams, because majority of you now, you want to go for medicine, you want to go for all those courses that are highly competitive. And a lot of people that their head are owing already. They are just trying to know one or two things more. Some things, oh yeah, when they say it, oh yeah, put more in there already. All of you should remember this. If you have alkanol and you dehydrate it, let me just use one simple example. If I have ethanol, this is ethanol, abi. If I have ethanol at under conc A2SO4 at 180 degrees C, just so your product is one thing, you will have 18. That's your product. It means you will remove water and you will have 18. Is that taken? But if you have this same ethanol, maybe they not even tell you that the ethanol is in excess at 145 degrees C in the presence of A2SO4. Your product is no longer 18. No? Your product will be alkoxy alkane. You will just remove the H. You know excess, just say like two of these guys, join them together. It's like this, 1, 2, OH, then OH, 1, 2. You know, this is ethanol. This is ethanol. Remove this OH, remove this H. You have removed water. Then what do you have? This and this come together. Then you have this and this, abi? And this becomes what? 1, 2, O, 1, 2. This is what? Ethoxyethane, abi? Very good. So which means when you see this condition, it is no longer 18. It becomes alkoxyalkane. This will become 1, 2, O, 1, 2. And this is called ethoxy. This is normal jumbo. This one is normal jumbo. Where you will be adding everything up together for you. You can see I have two different products. One, what determines the product that we have? The conditions. Abi, is what determines. And that's normal jam. That's not where I'm going. Oh yeah, yeah. Everybody, what do you have? So the hydration of this guy will give you, under this condition, what will you have? An alkene, Abi. I'm not making it 18, I'm making it, what's the name of this compound? Oh yeah, children of God. What's the name? We have a long way to go. We have a lot to cover. At least, even if we touch all this, we can solve questions from the past questions. This will be what? 3. Victor. Should we have Victor? What I put your real 3 methyl 1, 2, 3, 4, 5, 6, Abi. 3 methyl X 3 O, Abi. Thank you. So, but let me show you something. H is here, right? You remember? What's going on here? H is also here, Abi. This one too also has H, Abi. What do? You want to remove water. You can remove, if it's just normal jam, they will only stay at this side and this side. They will not come here. So you can remove this guy. That's one. You can also, let me call that one. We want to remove water. We can also remove this guy. Abi, that's another condition. We can also remove this guy and this guy. That's another condition. Which means my double bond can be here if I remove this one. She gets. If I remove these ones, my double bond can be here. And if I remove these ones, my double bond can be here. Do you get? So that means you can have 3 possible products. So let's get those 3 products right. The first one, let's say I'm removing for the first one. That means I'm going to have 1, 2, 3, 4, double bond C, C, C. Is that correct? Eh? What's the name of that one? Fatima. Oh yeah, what's the name? 3-methyl X4-ene. Clap for yourself. Stand up. Fatia. My baby love Fatia tó bá ti mọ̀. Fatia, oh yeah. You don't know too. Immediately the other day. My baby. Stand up. What's the name? 3-methyl X3-ene. Anat. Ó dà pé wọ́n rán mi sí. Dìde ṣe ta lórí kò jókòó. Stand up. 3-methyl X3-ene. What's your name again? Esther. Very good, Esther. Don't worry, I'll get used to you with time. Esther, what's the name? 3-methyl X3-ene. Are they correct? Have your seats. I wanted to be sure, maybe because I said they should stand up, you too. So this is 3. You can count it from 1, 2, 3, as long as you have seen your double bond. 1, 2, 3. So anywhere. But you should count from here. If you count from here, you'll be wrong. Is that taken? Because of the lowest number. But that's by the way. All of you should know that. So this is 3-methyl. I don't need to waste time writing that. X3-ene. Is that okay? Oh yeah, let's look at our second possible product. We can remove this OH, Abby, and this H. Then we have our double bond here. So that's the second. You can have your say, Ejoko. Mélòó láyé? 1, double bond. Ìgbà yẹn Fatima máa fún mi lọ́rùn lóru. Fatima, oh yeah, what's the name of this one? Stand up. So bí mo ṣe explain yẹn náà ò tí mọ̀. What's the name? You're a liar. Is she correct? Fatima, are you sure? We're sure for Joko, we're sure for. So that's what? 3-methyl X2-ene. She gets. So I'm happy that you people, at least the basic things, you know them. So what do we do now? We can remove this guy, Abby, the third one. So we now have Omadori Fatima Podosi. Fatima, what's the name of this one? Wallahi, brain it. What's the name? That's the third kind of product you can have. You will now tell me which one is the major product. You can see that there are different compounds from their names. It shows that they are not the same. Which one will be CZ2 properly? But tell me, what's the name? 3-methyl 1, 2, 3. 3-methyl X3-ene. Yaruka, you want to know? Stand up and tell me the answer. Yeah, what's the answer? What's your name? Aisha. Aisha, what's the answer? You are following her. Blue. Which boy will make us proud? Joko. What do you think the answer is? 2-ethyl pent 1-ene. What did you consider before you named it? The double bond. Double bond is the one that is serving like a functional group here. And anytime you are naming, you consider the functional group. That's where you start numbering from. This thing can be written like this. A lè kọ bí eléyìí. Double bond C, 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 C. 1, 2, 3, 4. Shey you get. Then on this, 1, 2. Shey you get. Please, do you understand this? So you consider the double bond when you are naming. So this will be 1, 2. So this will be 2 ethyl. How many now? Pent 1. Did you say pent 1 or pent 2? Pent 1. Is that taken? So this is 2 ethyl pent. So look at these 3 products, everybody. Which one is our major product? Ademide, have your seats, Aisha and Fatima. So everybody, which one is our major product? Let me give them A, B, C. Oh yeah, so I can move on to the next thing. So I believe we understand Marconikov's rule already. And Z3 is what we are using to determine which one is the major product or which one is the minor product. What's your name? Precious. Victor. What's your name again? You are, your brother is in UI. I want to remember your surname. Oluwajoba. Oluwajobi. Do you know how to play any instrument? Your brother can play keyboard, Abi. He plays different instruments. When he came to PRIMAX, instruments when woman playing here, Okoman Figi Lugi, low step. Oh yeah, everybody, what's the answer? A. Do we all agree? Just look at it. Double bond in functional group Abi. That's our functional group, the double bond. So that means that which one is the double bond more stable? The one that is well protected. You will see that if you come from here now, you can attack this easily. But if you come from here, this one is still more protected. But this one is even at the edge. Do you get that now? And they can ask you that which one is your minor product too. Your major product is the one that is most stable. Then the one that is less stable is your minor product. So out of these 3 now, this one will be your minor product. Shotiyewa, can we move on to the next thing? I hope that's the question they asked online about Marconikovs and CZ2. So this one is saying redox reaction, but let's leave redox reaction for now. That's a whole topic. If you all support that, we teach it. I'll quickly teach it. Let me see. The answer they can ask you in redox reaction is just to give you different compounds and say you should determine the oxidation number. Or they say that which one is reducing agent, oxidizing agent. Shey you get. So there's nothing much that I don't even usually see OAU questions on redox like that. Or they can ask you to balance redox equation. They can ask you. And they can use that balancing of redox equation to ask you stoichiometry. If you already know how to determine oxidizing and reducing agents. The second can also be, but this one is, if I have 3 of them, this one is the minorest. It does not exist, but you should understand. If they say I should arrange them in order of stability, 1 will be more stable, Abi, then 2 will be the next one that is stable, and this will be the last one that is stable. So this will be the minorest product. So if they say pick minor product, out of these 3, this will be your answer. Is that taken? Yes. No, you can arrange it anyhow. If anyone it does not mean that the major product has to be at the top. It's because I started with, I did not even know which one would be major. I just decided to be doing it. I will confirm to bed, she gets. So can we move on? So the next one you said, so on redox reaction, When we are through with organic parts, then I'll go to physical. So for the physical chemistry, I will check if you on redox, some things you normally understand. Then for that one of balancing redox equation, we'll do it. Then we'll use it to solve stoichiometry problems. Yes. Sazer's rule. If you want to have a good understanding of this, understand what we call steric effects. Don't ask me what is steric effect. Understand steric effects and Sazer's rule. Steric effect is just talking about the electron donating groups around a central atom. And our Q groups are electron donating. They are usually nucleophiles. They donate electrons. The ones that like electrons are electrophiles that accept electron. Please remind me your name again. Are you Hausa? You are Yoruba? You are Igbo? You are from which state? Kogi State. Okay. Kaba. I know your language. Like the way you are looking, are you fine? Are you sure you are following what we are doing? Are you confused? Are you sure? That's why I asked again. Kogi Zena. So, what was I explaining? The steric effects. Let me quickly use this to explain something. We already know what electrophiles are. When we say inductive effects, we are talking about electron withdrawing effects. An atom can donate electron, an atom can withdraw electron. If I put chlorine and hydrogen together, chlorine is more electronegative, Abi. Chlorine will pull electron from hydrogen. It means that chlorine is imputing what we call negative inductive effects. It will be taking electron away from hydrogen, pulling it away. Hydrogen will be donating electron to it. I'm just using that simple analogy. Hydrogen that is donating the electron will be described as positive inductive effect. Our Q groups, all these carbon, they usually donate electrons. They don't take electrons. But if I put fluorine here, between carbon and fluorine, which one will pull electron towards itself? Fluorine. Why? Because it's more electronegative. So that means that fluorine will pull electron, carbon will donate. So everywhere you see our Q groups, most times, they are usually donating electrons. And let me explain why it's the major product. Look at this scenario. You will see the difference between this and this now. Let me remove this. For the person that asked the question online. Now look at the difference. Let's say I have carbon, OH, carbon, carbon, carbon. I want to make it simple. Carbon, OH, hydrogen, hydrogen, hydrogen. Let me now remove this guy. Look at these two guys. Which one has, if I ask you that, which one do you think will be more stable out of these two? A or B? Naturally, A or B? Which one will be more stable? If you follow what we have been doing, it's the same thing. Which one do you think will be more stable? A. Because these guys are surrounding. This one is known as, you remember that this one does not have anything again, but this one still has H, H, H. So it's like everywhere is protected. And what is protecting that environment are electrons. Look at it. Let me remove this guy and put positive here. Put positive here. Now, this is called a carbocation, but primary, tertiary. Now, If I want to bring anything here, what will I bring? Probably chlorine, abi? Now, chlorine is negative. I want you to understand steric effect too, and that says it through. That makes us to say that this one is more stable. If I'm also bringing chlorine here, what's chlorine carrying? Negative. If something is carrying negative, well, I want to explain why you feel this one is more stable than this one. If chlorine is carrying negative, what does that tell you? It has high electrons, abi? Negative means more electrons. In this case too. So they want to attack this place. But as this one is coming, how many electrons does this carbon have normally outside? 4, abi? 1, 2, 3, 4. And there's still another hydrogen. 1. There's another hydrogen. I hope you remember. There's another, just follow what I'm doing, or you will get the point. There's another hydrogen. There's another hydrogen. Then there's another hydrogen. Then for this one too, there's another hydrogen. There's another hydrogen. There's another hydrogen. Do you get that? But for this one, just 1, 1, 1. Look at this guy. This is positive, abi? So imagine something negative is coming from here. I'm just using that as an example now. Ofe will attack this guy. When he gets to this region, what will he meet? Cloud of electrons. And because it's also negative, what will happen? If it's coming from here, will he experience the same cloud of electrons it takes? Can you see? So all these ones now, all the electrons that are clouding this guy, they make it difficult to react. Ó mọ̀ pé ṣẹ̀ṣẹ̀ ní 19 ni. So do you understand what we are saying? If you look at this guy and look at this guy, if chlorine will attack this guy and this guy, which one do you think it will easily attack? B. I don't know if you're getting my point, if you're seeing what I'm saying. Precious, are you seeing it? Because of the excess of electrons here, as the chlorine is coming, it will repel it. So it will not easily get to this guy. Even if it's coming from here, electrons are still around. But for this one, as it's coming, this one, even if they will repel, it will be less. So that's why we say that this one is more stable than this one. So if you do the same thing here, this one we have H, bam, 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 H, electrons almost everywhere, H, and you want to attack this double bond. This one too, we have H, electrons, you get. Well, compared to this one too we have, but where is that one? Okay, this one, you remember, this one will still have its own. This one will have its own. So anything coming like this, we encounter first one. I don't know if you're following. It will encounter the first one, the second one, and even the third one. When anything coming like this, we only encounter 1, abi, and 2. So comparing this and this, you know that this one will be easily attacked compared to this one. Do you get the point? So that's why this one is known as, but in order not to be talking too much stories, because we don't have time, that's why I'm not explaining. We are not doing the whole of organic chemistry from beginning and explaining little by little, but just picking the important. As long as every one of you now, since I've been asking which one is major product, all of you know it, Abi. That's the most important thing. In the exam, they won't ask you that which one is the steric effect or which one is. All those steric effects are just the idea or the rule that makes me to know that this is a major product. But from what I've said so far, I already know. Under G, are you fine? Is that okay now for the person online too? So where are we going? So the next thing we'll go to, you said tautomerism. Tautomerism is a form of isomerism. We call it ketoenol formation. When you get to alkyne, let me quickly show you something. Where you can get the word tautomerism. Because they can ask you, they can just ask you that tautomerism will give you which of the following will that book tautomerism, ketoenol. Let me show you. Can I rub the board now? So let's assume if they want to ask you a question on alkene, that's the major part. I'm still going to talk about hybridization, but for now, that's the major part. I'm still going to teach you some other things. Aside the normal things you knew during Jambo, those are the things OAU can ask you. So now let's quickly look at tautomerism. When you are talking about alkynes, you can see the word tautomerism there. When you are talking about isomerization, isomerism, you can see the word tautomerism there. So tautomerism simply means rearrangement. That's the word. Tautomerism. It simply means rearrangement. So what they ask you, if they ask you that, what will lead to the formation of what we call ketoenol formation? So if you see a question, your answer will be ketoenol formation. Now, let me show you what that means. It means I can convert a ketone or an alkanol. I can convert it to alkenol, not alkanol. Alkenol. Alkene that has O. So let me show you. Let's say I have this guy. What's the name of this compound? Ethyne. Then I hydrate this guy. I am adding water. By the time I add water, I'm going to have do you agree? Eh? So this is ethanol, Abby. It's enough. I already formed my enough. But there's one thing this guy can do in the presence of a base. It can be rearranged. And that's what we call tautomerism. So it can be rearranged forward or backward. Rearranged. There is no need to show you the mechanism. How does it get rearranged? H will just come from here and come here. Then this will leave. Like this double bond can come here. If the double bond comes here, then you are going to have C, all these things. I just don't want to be showing you too much. This double bond, H that left there. If normally carbon is supposed to have 4 electrons, but because I moved these 2 electrons here, carbon is now having 5. Then it will carry negative, leaving what I still have before. And if you check the structure, you remember oxygen, we have something like this. Abby, if it has something like this, it can drop the double, these electrons here. And this one can drop its own here. And this one will break off to form H+. There's a way, all those things. It will donate the electrons. This will become double bond. Then the H+ will come and attach here. Then it becomes ethanol. But that's not your problem. Don't worry. You are just rearranging. And what did you rearrange? It's not to what? Ethanol. And that's what we call tautomerism. So it's this guy now, they have the same molecular formula, but different arrangement, different structure. So it's an isomerism. So tautomerism, it's a kind of reaction in which 2 compounds have the same molecular formula, but different structure. She gets. So this compound now is ethanol. Why this compound is what? Ethanol. Do they have the same formula? Eh? Yes, now this is H, C2H4, C2H4O, C2H4O. She get. So they have the same molecular formula. C2H4O, but they have different structures, and we call this ketoenol formation. So that name you give it in isomerism is called tautomerism. So that's by the way. So there's nothing much on that. Then the next one is hybridization. In order not to waste much time, this is almost one. In order not to waste much time, I'll show you what you need to make by hybridization and overlapping orbitals. But can I rub this board? Or does anybody have a question on this? There's nothing much here. Highest they can ask you is probably tautomerism gives you what? Then your options. You have ketoenol and all of those things. So can I rub the board? So tautomerism means what? Rearrangement. Abi, what I have here becomes rearranged to give me this. Can I rub the board? Oh yeah. So let's look at hybridization. I'm not teaching hybridization that I'm going to start from one carbon jump from 2s of carbon to 2p, then S mix with 3p, then it forms sp3, sp2. You should know that by now. Do you know that? That's the introduction to organic chemistry. Aisha. You should know that before you start organic chemistry at all. That's the basic thing they will tell you. That you remember carbon in its ground states. One electron is in, you have 1s to 2s to Abi, 2p, 2 or so, Abi. Then you will now move one electron from the 2s to the 2p. Then you now have 1s to 2s1, 2p3. Then you can now mix that x with 3p. Then it forms sp3. You can mix that s with 2p, forms sp2. That s with 1p, then it forms sp. Then when you now take it to chemical bonding, you can now start doing different things. That's hybridization. So hybridization is the mixing and blending of atomic orbitals to form a single hybrid orbital. So you mix different atomic orbitals together and you form a single orbital, which you call an hybrid orbital. But for this sake, you just need to know one thing. Number one is that understanding hybridization helps you to understand sigma bond and pi bond. And the only thing you need to know is how pi bond is formed. Every other one gives you sigma bond. That's why I will do a drawing for you. Questions on quantum numbers. All of you should know that by now. Do you all know quantum numbers? Not just know quantum numbers, like if I say that n is equal to 4 and l is equal to 0, which orbital is that? C, sp2. That's an s orbital. Which electronic shell? Which electronic shell is that? KLMN. When n is 4, which shell is that? N, that's n. But which orbital, if I ask you, that is 4s orbital. It's not just s, there are several s. There's 2s, there's 3s, there's 4s, that is 4s. So that means that some of you don't know this. So because of the person that asked, I'll quickly explain this. But it's a long process, but I'll try my best to quickly explain it. Should I continue with hybridization? I should explain this. Okay, when we finish hybridization, then I will explain this because of the person that asked. So from your past question, you'll be able to solve it. So let's finish hybridization. So when you're dealing with hybridization, I don't want to start from the beginning so that if you don't know that before, it might be complicated and it will start giving us problems. But let me start this way. You know the definition. Hybridization is simply the mixing and blending of atomic orbitals to form a single hybrid orbital, which is very simple. But I don't care what it is. Let's say they give you this compound. And say that determine the hybridization. Now, what you knew is that, what's the hybridization for alkane? What's the hybridization for alkane and alkyne? What compound is this? What's the hybridization? Now, 1, 2, 3, 4. What's the hybridization of the first one? But I asked you that what's the hybridization? You say sp2. So in alkene, you can have sp3, you can have sp2, you can even have sp, depending on what you have. So this is what you need to know. There's what we call, when you are forming bonds, there's what we call a sigma bond. And there's what we call a pi bond. Now, sigma bond is formed whenever there is actual sharing of electrons. Sharing of electrons by overlapping orbitals. And these overlapping orbitals, they overlap linearly or collinearly. But for pi, they overlap in a parallel manner. The orbitals overlap in parallel manner. And for pi, you always have this. That is pi bond. For sigma bond, you can have this. That is sigma bond. This is sigma. This is pi. I know you are confused. I think there's no way I will not start from beginning. But there's something I really want to show you. I will explain this, but before that, let me tell you what you need to know when you see in the exam. When you have a single bond, every time you see a single bond in a compound, that is a sigma bond. Single bond. So this bond, what would lead to be sigma or pi? That's what I need you to know for now. Is that taken? When you have a double bond, in a double bond, there's a pi and there's a sigma. In a all single bonds are what? Sigma. In a double bond, there's what? A pi and what? A sigma. So now, in this double bond now, we have two bonds, Abi. One is what? Pi. One is what? Sigma. Is that okay? Very good. In a triple bond, there are 2 pi and 1 sigma. So let me continue this guy by doing this. So which means in this place, there are 2 pi, 1 sigma. Is that taken? So if I ask you a question in this compound, first, what is the name of this compound? What's the name? Anatana, Tanatana, Anatana. Oh yeah. The thing about OAU chemistry is that if you know organic well and you can express yourself, you can score 10-10. But if you just leave secondary school and you are just sitting with AU chemistry, you can score 1. You can score 1. I've seen best graduating students face that before. Like, even in PRIMAX, we have had that history. Come and do tutorial. No, I'm the best graduating student in my secondary school. I know chemistry, I know physics, I know biology. No problem. Only for results to come out, and I was seeing 2/10. But the person had to write again, and the person gained admission on merits later, after wọ́n ṣe wá farabalẹ̀ ṣe tutorial. So, but hopefully the question will come just the same way they came last year. Last year questions, if you are good, if you are just good naturally, you will pass. You will pass. Even if you are very good from secondary school, you will pass. The questions were not, you are Roman numerals. You are Oti Elemo. You are Lerara. So do we get that now? Oh yeah, everybody, in this have you, what's the name? 4 in 1 9. What's 1 9? Triple bond. Then what is now 1 high? You just say 4 in 1 9. Are you say 4 1 9? 4 in, this is 1 2 3 4. You know, this one will take priority over this. So this will be 4 in x 1 I, Abi. But that's not my problem. Now, how many sigma bonds do I have in this compound? How many sigma bonds? I will quickly use this to teach you some things in chemical bonding too. How many sigma bonds? It's just a shortcut that I'm teaching you, but I'll still show you this so that you understand something. How many? 14, 13, 15. Victor sọ̀rọ̀ 13. 11. Are you all true? So let's see who is correct. 1 2 3 4 5 6 7 8 9 10 11 12 13. So all of you missed this part that I did not put. You did not know that this carbon must be up to 4, Abi. It must be up to 4, but I didn't show this one. So there's a bond here. Is that taken? The bonds are balanced now, Abi. This one is 4 bonds already. This one is also how many? 4. This one is also 4. This one is also 4. This one is 4. So it's balanced. Is that clear? So now there are 13 sigma bonds. How many pi? 3 pi. Shey get? Have you been able to determine that? Oh yeah, let's look at the logic that we should show. What we have here, when they now try hybridization, when they ask you, anywhere you see 4 sigma bond, it can also be 3 sigma 1 loop here. I'll come back to that. Let me just say it. When you see organic compounds and you see 4 sigma bond, when you see 3 sigma bond around an atom, or you see 2 sigma bond, when you see 4 sigma bond, just know that is sp3. When you see 3 sigma bond, that is what? sp2. And when you see 2 sigma bond, that is sp. So in this compound now, we have everything. How many sigma bonds is around this carbon? 1, 2, 3, 4. Abi? That means this carbon is what? sp3. You can look at it like it is methane and alkane. And alkane will always be sp3. Share again. Yeah, how many sigma do you have? 3 now. You know this one will be 1 pi, 1 sigma. So 1, 2, 3. Abi? That means this carbon is what? sp2. If I now ask you, this carbon and this carbon, what are overlapping? This carbon is sp2, this carbon is sp3. So it is sp3 overlapping with sp3. Whenever sp3 overlaps with sp3, anything that overlaps, it is what? Whatever it is, hybrid. So if you have sigma bond will be formed when you have hybrid. This is an hybrid. You are joined several together to form sp2. This is also an hybrid. So hybrid to hybrid, we give you a sigma bond. They can ask you. Hybrid to hybrid. So this is a sigma bond. Now look at this guy. Do you understand what I just did now? For this part. This is sp3. Since you have already joined 3 p's and 1 s, you are doing several things together. And that is called what? An hybrid. I'm just giving you things you need to look out for. That's all. For now. If time permits, I will explain why I call it an hybrid. I will quickly do that. Now, for this one, is there an hybrid? This carbon? Yes. Now, this carbon is bonding with which atom? Hydrogen. But you remember, hydrogen only has 1 s. So that means this carbon and hydrogen, what are their overlapping orbital? sp3 overlapping with s. Do you get that? That means when you just have hybrid and a single orbital, then that is also sigma. Don't get lost. Anything you shall see, hybrid, pp lateral, pp. Only when you see pp parallel, when you see p overlapping with p and it is parallel, then that is the only time you have this. I will quickly show you how that is formed actually. I'll show you how that is formed. But I don't want to complicate your brain. That's why I'm trying to make us do the logic instead of the story. sp2. How about this? Very good. How about this? Because sp. This is also sp. So for all the carbons you have here, it is sp. Now look at this. Let's imagine that what I have here is not hydrogen. You remember chlorine? Chlorine is this 17, 1s2, 2s2, 2p6, 3s2, 3p5. If you look at that orbital, what's happening? In 3p5, 1, 2, 3, 1, 2. There's only one space for electron. That space is what? P. So if this carbon is giving electron to chlorine, that means what is this carbon? An hybrid. Overlapping with which orbital of chlorine? P of chlorine. Do you get that? So that means between this carbon and this chlorine, what you have is sp overlapping with p. I don't know if you understand what I'm showing you. Between this carbon and this hydrogen, what you are having overlapping is sp3 overlapping with s of hydrogen. So this is sp3 overlapping with s. Because the electron hydrogen is using for bonding is in s orbital. I don't know if you're getting my point. Let me do something simple so I'll see if you're getting my point. So look at this compound. First thing is carbon and fluorine are forming a bond, meaning that one electron comes from carbon, one electron comes from fluorine. normal chemical bond. But in this case now, this carbon is already hybridized. What is the hybridization of this carbon? The electron fluorine is using is in which orbital? Because fluorine is what? 7, Abby. 1s2, 2s2, 2p, 2p. That should be 2p5. Fluorine is 9, sorry. So that's what you have. Meaning that you are going to have how many electrons here? 1, 2, 3, 4. 1 electron will be left. Abby. So this electron is what they will come and share. Carbon will donate its own. Fluorine will donate its own. So they will form a bond. And that bond is what you are seeing here. Meaning that this guy is sp. From what I've told you, that's how you know. You don't really know how to form the sp. But from what I told you, you can determine that anytime. Now this is sp. But fluorine is using the p orbital, Abby. So that means sp is overlapping with p. And anytime you have sp overlapping with p, sp overlapping. In this case now, what are overlapping orbitals? Between this, let me call this carbon 2, carbon 3. Between carbon 2 and carbon 3, what are the overlapping orbitals? This is sp overlapping with sp2. Check it, it's not hard, it's not hard. Let me get that. That's what you can see for organic chemistry for your level. So, but this is a sigma bond. That's a sigma bond. In this place, why we have pi bond here is that we have sp overlapping with sp. That's one of them. But the rest of them, they are not actually true bond. The first one is like this. 1p overlapping with 1p. Then the second one is another p overlapping with another p. But don't worry, I'll show you that just for you to know. But it might look a bit tough for some of you. But that's my problem. So let's do that. So I will show you that so that you know it, even if you are not getting it. So, but this is the most important thing. So I can give you a compound and ask you to tell me the hybridization, the overlapping orbitals, and identify the sigma, identify the band. As simple as that. Now let me take you back to chemical bond. You can just write this now, BeCl2, and they ask you what is the hybridization. For these ones, they are not hard. Do you understand how organic chemistry? Now, please, you must know how to identify hybridization. Those counts the number of sigma and the number of pi. Change it. Any atom that has 4 sigma around it is sp3. Anyone that has 3 sigma is sp2. And I told you that what are sigma? All single bond. In a double bond you have 1 sigma, 1 pi. And in a triple bond you have 2 pi, 1 sigma. Just that. But now, you know when you are treating hybridization, they can ask you this. They can say, let's look at ammonia in inorganic chemistry. Look at this guy. They can say, what is the hybridization of nitrogen? Now, I don't want to start telling you stories of how we form it. But for now, count this is called lone pair. Again, these are called bond pairs. Count the number of this single bond plus the lone pair. So if you have 3 sigma, 1 lone pair, that is sp3. So this nitrogen is sp3. That means this is just counting it like this. S, P, P, B. Making what? sp3. So your lone pair and the bond pairs can tell you the hybridization. Shake it. Let me give you another example. Look at this guy. I can run this guy now. Just know that anytime you have a parallel PP, that is when you have what? Pi. That's what you just need to know. Any other one is what? Sigma. So just be looking for parallel PP. If we have time, I will explain deeper. But for now, that's all you need to pass your exam. Now, look at this. Look at this guy, methane. We have a lone pair here. In methane, no lone pair here. That means you only have how many bonds here? 4. So if you have 4 bond pair, that is what? sp3. Just count. S, P, P, P. This is what? sp3. Start taking. Let me show you another compound. I want to do this BF3. Everybody, what would be the atomization of boron here? What would be the atomization? That's boron trifluoride. You now will form it in chemical bond. What's the atomization? Eh? Do you know the bond? The structure. The structure is like this, Sandy. BF3. Does it have a lone pair? Eh? No. If you know that, then you don't have a problem. Then that means this is just sp3. So the answer is what? sp2. I hope you are getting it. That's for inorganic, for chemical bond. In this case, we always look for hybridization of the central. What's the hybridization of the beryllium here? And what are the overlapping orbitals? If I say what's the hybridization and what are the overlapping orbitals, what will be the answer for BCl2? What do you answer? If anything is not clear online, you can. Hey, Mike, go to the doctor. You could have plugged it. Okay, plug, so it's in mind. There's a space by this side. And you can hear.
Má worry, ìyẹn náà máa ṣiṣẹ́ bẹ́ẹ̀.
So BeCl2, who has gotten it? What's the hybridization? Eh? Explicit báwo, ṣé biology? Some of you are saying sp2, some of you are saying sp, some of you are saying sp2b, sp2p. Is that correct? What's the hybridization for beryllium? In that place, what's the hybridization? Is sp, except you don't know chemical bonding. You know that for beryllium chloride is going to be BeCl2, Abi? That's the structure. Does it have a lone pair? No, now, except you don't know this. This is normal chemical bonding. So, if you already know this, how many do you have? Just 2. And that means this is S, this is P. That's what? Sp. So, it means this beryllium is what? Sp. But chlorine that is forming bond with it is using which electron? P. That means it's overlapping with Sp. So, the hybridization of the central atom is Sp. Then that means so Sp is overlapping with P of chlorine. Are we clear with that? Please, do we understand that? Don't be scared. There's nothing there. Look at this, everybody. Between this guy H2O. Which one is the central atom? That's what you need to first identify. Èyí tó bá kéré jù, the least element, is usually your central atom. Oxygen. Abi? So, if I ask you, what's the hybridization of oxygen here? Oh yeah, everybody, what's the hybridization of oxygen? You can see that it's not hard. You did not get it. The only reason you might not get it is if you don't even know chemical bonding. If you don't know how to identify lone pair and bond pairs, that's the only reason. And that's another story on its own. So what's the hybridization of the oxygen? sp3. sp3. If you remember the structure for water, then if this one is sp3, then what is the overlapping orbital? sp3, yes. She gets. Water is this. Oxygen, Abi. Hydrogen, hydrogen. Remember your V shape. Then it has two lone pairs, Abi. Is that correct? So if you now count in total, no pair plus bond pair, that means S, P, P, P. That means oxygen is what? sp3. Hydrogen is using which electron? Electron that is present in the S orbital. Abi, that means it is sp3 overlapping with S. So can we move on now? So sp3 overlapping with S. Are we okay with hybridization now? For now, that's all you need. For now. And what I just said about PP parallel, that's all you need. And identifying sigma pi. Then, if you now have this, everybody, what's the hybridization of S? SF6. People online, that's how we treat children. They play until chemistry comes. Hey, everybody, quickly. At least if you can cover all these things in organic chemistry, it's been long I had class. Ẹ pé mo ti yọ ọkùn gan. Kò sí wàhálà. Teaching every time. I'm happy with that UI result. You guys did well. You made me proud. Where you people will make us proud too. You will do very well. Do very well. So our jam class will be starting August 3rd. Have you gotten it? Some of you might be confused here. Oh, then today, so sp3 when? So what's the hybridization? sp3d2. You know, after you leave S, you only have one S. You have 3p. You have 5d. You have 7f. Abi? So which means that when you have used the old p, then you move to d. That's why I have to give you this. So this will be S. S has 6 electrons. So which means it can be F, 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 F. Abi? So it can go S. After S, you move to P. S is only 1. So you move to P. P, P, P. P is always 3. Then after P, if you have used the 3 and you are still having left, then you move to D. Then if you use the O5D and you are still having left, you move to F. So, but you can't get there. So this is what? SP3D2. And normally in your exam, they can represent it this way. This one now that I said is SP3. How many do we have? S is 1, P is what? 3, Abi. So they will put a number like this at the front, meaning that 4 of them, 4 SP3. In another option, they can say 2 SP3. Some people might be confused with that number. The number is just telling you the total number. So you get 1S and 3P. And remember that they can ask you for, what's that one called again? The amount of S in percentage. That they can ask you to calculate it. Resonance. No, not resonance. Like they can say you should calculate S. S character, P character.
Ṣé orí yẹn náà ṣá? Are you going to go for it?
I've been seeing your.
Mo wọ ẹni tó sọ̀rọ̀.
Mi mọ̀ bóyá wọ́n follow ilé wa. So we are still on chromatography calculation. So, and we call it retention factor. We call it retention factor. If you have any from your past question, you can give me. But before then, let's understand again. I said we use chromatography in separating color pigments. Color pigments. So I said, let's take a paper, for example, then mix different pigments together of different colors. Then put the pigments on the paper at a particular site, which we call the origin. We call it the origin. Then when you place that paper inside a liquid, so let me start again from there. So you now take this paper now, you now put it inside a liquid. Then the liquid will serve from a particular origin. So be what we call the mobile phase. This is called the stationary phase. So when you take this paper and you dip it inside the liquid, so you take this paper now, you put it inside the liquid, then the color pigment will start from a particular origin where you started from here. Then it will start moving up. But let's say the pigments we have is carotene, xanthophyll, and chlorophyll, Abi. Let's say chlorophyll. Now, the three of them are mixed together here, but as this liquid rises up, as it rises to a particular level, on top of this paper or the stationary phase, all of the colors of these guys will be separated. Maybe green, yellow, orange. The one that is green that you see there, you already know that that's your chlorophyll. Abi, then you have xanthophyll, then you have your carotenoids. Now, all these pigments that are separated, they left a particular origin, a particular point. That point is called the origin. That solvent rises up to this level. Where that solvent stops, we call it the solvent front. The solvent front, or the solvent front. Now, in calculation, you want to know the rate at which these things are collected on the surface. You can see that they all stop at a particular region. That means the rate at which they are collected are different. So you now want to calculate how are they retained. That's we call it retention factor. Now, let me now make it a simple, just one diagram and 1 point. So this is the paper. Then you have your substance starting from a particular origin. Then the substance moves from year to year, while the liquid moves from year to year. This is the origin, Abi, if you are following. Like I'm not mixing colors now. Let's just say it's just one spot. That one spot was carried from here to here. So I want to know the rates at which it is retained on that surface. This is called chromatogram. Chromatogram. So now, this guy has moved from here to here. We call this distance from here to here. We call it X. Then the liquid also moved from here to here. We call this distance from here to here. We call it Y. So Y is the distance moved by the solvent, Abi, to the what? To the solvent front. Yx is the distance moved by the solute from where? From origin to this place. That's your X. Then if you now want to calculate retention factor, so retention factor is given as X over Y. So X is distance moved by solutes from origin. So you always take it from the origin. Or from 0.5. You must take notes of that. Why? What is my minor? Distance moved by the solvents. By the solvent front. From where? From origin. So that is the formula for calculating So that's the formula for calculating retention factor. I don't know if you have your past question here. If you have a question, please give me. Let me use it as an example. Number 8. Belefatia. So everybody, let's solve this question. You will now understand it better, right? A chloroform solution. Please don't forget, in chromatography, if you perform your chromatography, if you see a single spot, that means that substance is pure. That means it's the only one. Shey you get? Like if you see a single, after you have run it up and you see just a single spot, that shows that substance is pure. If you see several spots, that shows that it's a mixture. Something must have been mixed. Then that shows it is impure. Do you get that? So this substance is said to be pure. This substance is said to be impure. So let's write the question. Look at this question now. Which of the following bond is not present in benzyl alcohol shown? Look at this structure. From what I just finished teaching you, this is benzene. If I show my boy keep toilet, just to wee. This is a structure. They now said, which of the following bond type is not present in this benzyl alcohol? So it's an alcohol. So they are now saying that A, sp2, sp2 overlap. B, sp2, sp overlap. C, sp3, sp2, sp3 overlap. D, sp2, s overlap. You will come back to that. Let me finish what I'm explaining. The next question, they said, how many sigma bond and pi? Retention factor depends on what? And the boiling point of isomers is the same. All these ones are simple, direct questions. There are questions they can ask you anytime. So let me continue with the question. Sorry for the distraction. I'm seeing questions based on all the things I've talked about today. So a chloroform solution of a pure organic compound was spotted at a distance of 0.80 centimeter. If you prepare very well, you will pass OAU. OAU is just that you must know what they used to ask. Don't just go there. At least know what they used to ask. That's just the thing. It's unlike UI. At least tó bá ti ṣe jam dáadáa tó mọ jam, just add some bit of preparation. UI too, you should know what they used to ask. If not for those past questions and no. That's why everybody is feeling fly, scoring 90. I even saw someone score 93. 93. You have seen 94. So that out of 100, kéèyàn ṣe 6. By next year like this, you are lọ tún ara mú wá, because they used to do that when they get to a stage and they see that ó dà pa àwọn eléyìí wọ́n ti catch scope wá, they will now bring it, and that year that they always bring it, people will fail because the way they will bring the question, everybody will be shocked. They were not doing Roman numerals before, at least till like 2020. They were doing normal objective. They will give you paper, simple question, calculate the atomic, what's it called? Calculate the oxidation number. I still remember those questions. But bó ṣe di 2020 after COVID, set àwọn Peter, but they still gain admission. So that's it. Always prepare for the worst. As that year was, as tough as that year was, boys still pass. Because during preparation there, I'm always saying that whatever it is, just bring 100 though. 100. So your mind gone will be ready. A chloroform solution of a pure organic compound was spotted at a distance 0.80 centimeter from the base. A chloroform solution of a pure organic compound was spotted at a distance 0.80 centimeter from the base of a 20 centimeter long chromatoplate. From the base of a 20 centimeter long chromatoplate, full stop. If the compound has the RF value, that's the retention factor. If the compound has the RF value of 0.505, RF value of 0.505, and moves halfway up the 20 centimeter long plates, and moves halfway up the 20 centimeter long plate, and moves halfway up the 20 centimeter long plate. What is the distance? Is there any one of you that has resumed for 2027 jam? Normally, yeah. So please, before this post-20 go, all this Ife, Samuel, all of them in the hostel, before they go, like let them teach you some basics, some things, so that it will be easier for you. And that's why we used to say that 2027 post-UTME jam should always join post-UTME, so that when they join, they will still meet post-UTME people in the hostel. They will teach them. So when they teach you people, at least, because if you don't get it right now, by the time we start that time, you might still be looking like this. So if you meet them, let them quickly teach you first 20 elements, how to determine electronegativity, how to, all those things matter. The moment you know those ones, the rest will fall in place little by little. So please, all this success is marathon. It's something that you have to do consistently, and it will eventually work out. If the compound has the RF value of 0.505 and moves halfway up the 20 centimeter long plate, and moves halfway up the 20 centimeter long plate, comma, What is the distance of the solvent fronts? I'm just happy this year that way you change to physical. But I wish I had been around. A lot of things. If the compound has the RF value of 0.5 and moves halfway up the 20 centimeter long plate, what is the distance of the solvent fronts? So always read to understand your question. What is the distance of the solvent fronts from the top of the plates? From the top of the plates upon elution of the compound. E-L-U-T-I-O-N. Upon elution. E-L-U-T-I-O-N. Upon elution of the compound. So that means that upon allowing the compound to rise. So when it starts rising, what do you experience? So let's analyze the question. I'll use this one to explain. So you can go and solve the rest on your own. And please try to understand it. Many students used to get confused with this question. It's simple. But if you don't understand what they are saying, so what you are going to start with is draw your chromatoplate. So let's rub this. We'll come back to this one. I still have a lot to teach you, Sha. But don't worry. Don't get tired. I'm the one that should be tired. I've been far away from teaching for a while. So, a chloroform solution of pure organic compound was spotted at a distance of 0.8 centimeter from the base of a 20 centimeter long chromatoplate. So this plate now is 20 centimeters. So draw it first. That's what you do first. So the total length of this guy is 20 centimeters. That's what they said. Please, so they now said you spotted something. Where did you spot it? A chloroform solution of pure organic was spotted at a distance of 0.8 centimeter from the base. Where is the base now? Here, Abby. So where did you spot it? At, from here to here. Now, if you measure it, that means from here to here will be what? 0.8 centimeter. That's where you spot it. Do you understand that? They said was spotted from the base. 0.8 centimeter from the base of a 20 centimeter long chromatoplate. So that's where we see it. Do you get that first part? If you cannot interpret it, it might be a problem. So if the compound has the RF value of 0. So they already gave you this now. RF value equals 0.505. No units. Both are distances, so they will cancel out. And moves halfway up the 20 centimeter. So this guy now moves halfway up. So if I ask you halfway up, what does that mean? Where did he move to? 10. Share you get. The entire thing is 20, Abby. So it moves halfway up. That means this guy's left here now is now here. And that length from here to here now. That means, let me track it out. From here to here to the base. That's going to be what? 10. Abby? Shoye? Please, do you get that? I will ask you a simple question now. They now say that what is the distance of the solvent front from the top of the plate upon elution? Definitely, for this one to move to this place, the solvent must have gone beyond. Abby? I'm just using that language now. If you use water you pour oil with water. It's the water that will carry the oil. Abby? Like maybe all these oil particles inside water. Just pour the oil and the water. The water carries the oil. Anywhere the water does not get to, oil cannot get there. I don't know if you're getting my point. So which means that the water that is, or the liquid that is carrying this thing would have gone up. Abby? Let's say the liquid is around here. And the distance from here to here becomes my y. Abby? Are you getting my point? So this point is called the what? The solvent front. But if you think about the question says calculate the distance from the top to the solvent front. That means what you are looking for is actually from here to here. But how will you know that? That means you need to know from here to here. If you know from here to here, then the problem is solved. But how do you now know from here to here? Can I know from here to here? What does that represent? My x, Abby? Can I know it? When I say my x now, many of you will be thinking that my x. So my x, what's my x? You know, from here to here is 10. From here to here is 0.8. Then from here to here is what? 9.2. Do you get that point? So now I know my x, I know my rf. Can I know my y? But don't forget, even after knowing y, be careful. Rf is going to be x over y. So y is going to be what? X over rf. And what's my x? 9.2. My rf, 0.505. And that's around 18 point something. 18.2. So my y is 18.2 centimeter. Now be careful. Do you think from here to here is 18.2? What's my 18.2? That means from origin, you know, we said y is distance moved by the solvent from origin. Abi, it's from here to here. That's our y, not from here to here. Do you get the point clear? So that you are not getting it. Do you get what I'm saying? So that means from here to here is my y, right? So my y is equal to what? 18.2. So if I want to get here, let me call here my z. What do you think that place will be? 20 minus 18.2. That's what I'm saying, that you should look. He that has it eye, let him look at. You are looking from here to here. 18.2 is just from here to here. That means what you baby by. Sure you get. That means, let me trace this out now. From here to here is going to be what you don't know. That's going to be 18.2 plus 0.8. That's total. Abby? Do you get that? You can now know z. Because z plus 18.2 plus 0.8 is going to be 20. Abby? So z can now be 20 minus 19. And that's going to be 1 centimeter. Abby? Please, do we get that now? So it's as simple as that. Sorry, is it because of... So that is it. So you understand what we have done. Take it from the origin, then gives you x. Take it from the origin, then that gives you y. Then that's it. So if you don't understand, you can let me know. So that's just for example's sake. I think we are okay with the chromatography calculation now. So go and solve the ones in your book. I'm not sure where you will ask you that again, Sha. But in case they ask, where you love question banks. So in case they ask, you can just bring anything. Just be ready. Just be ready. Next, after calculations in chromatography, you say I should talk about solubility products, KSP. Is there any person that has problem with solubility products? The only thing, not only solubility products, where you can ask you about common ion effects. That's the advanced part. Common ion effects, not just solubility products. Check. You know how you do KSP now? You don't know how to do KSP. Normal jam now. You use KSP when you are trying to calculate the solubility of partially soluble salts. We call KSP solubility products, Abi, solubility products. So when you are trying to calculate the solubility of partially soluble salts, then we use KSP. Can I rub the board? Let me see if I can still remember common units. I think there's a question on that. You can let me check. That would be for the other one. So I can solve one for you. Common ion effect is straightforward too. Let me just explain something first, then I'll show you common ion effect. Can I rub the board now? Please, you have some salts that are not so soluble. You can go and do this one and explain it. Anything you don't understand, you can let me know later. If I have time, I can still, I would have said we should use tomorrow also, after church. But I think tomorrow is going to be a long day in church. I know your people that will want to dance and dance and dance tomorrow. Ìjó tí wọ́n jó tẹ́lẹ̀. Wúrà gan fẹ́ jó pa lọ́la. Èmi gan máa lọ lẹ́nu ijó. Sọ̀lá báyìí. So we might take time in church tomorrow to go and celebrate the UI students. So you will also be celebrated in Jesus' name, amen. So you'll be celebrated, don't worry. Keep working, keep working. Everybody day of celebration is coming. Whether you like it or not, it's coming. It's coming. Just don't give up. Just work harder, work harder. Be in the right environment. Meet with the right people. Learn the right way. Don't hate anybody. Don't count anybody down. Don't look at it that could lead for you. Support one another. Anybody that is winning, celebrate them, clap for them, let them progress. Your own time will come. I've had the experience that some of our students didn't gain admission and they still went for the matric of those that gain admission, their classmates. They went to celebrate them. And the following year, God did their own too. So there's no reason to hate anybody. And what I need you to always remember is that sometimes when things don't work, when they don't work out, and you know you did your best, but it still did not work out. You did your best, but it still did not work out. God has a purpose. God has a purpose. I've seen people that went for post-UTME and they had accidents, they died. I've seen them. So I remember those days, same way you know, before you change it from physical to online. So if things don't work out, don't start crying. God is working behind the scene for a better side. The only thing is just know what you are doing. Be consistent. Many people will face all their challenges. They will face it. Christianity will face challenges. We'll see. But it is what it is. That's not it. Though. This one is straightforward. This one is normal solubility question. It's not this Talo and Europe. Thank you. After they add the excess to it. But let me just explain this one first. Let me just explain this one you gave me. So when you have some partially soluble salts, for example, AgCl, and they ask you to determine how soluble, you're going to have it give you Ag plus Cl minus. So in solubility products, this will be, if this is X, this will be X in mole per dm cube, because the unit matters. This will also be X because it's 1:1:1 basis stoichiometry. So this will also be X mole per dm cube. Shall you get? Then if they say calculate the KSP for the solid, just do that. KSP is equal to X mole per dm cube into the second one, X mole per dm cube. Then the KSP, so you leave the product, is going to be X times X, X squared, mole times mole, mole squared, dmq times dmq. What's the answer? So KSP here is called your solubility products. Solubility products. So if they say calculate solubility products, that means you should calculate KSP. If they say calculate solubility, X is called solubility. If they say calculate solubility of this sort, that is X, which we have here. They will give you the value for KSP and they will say you should find X. Sometimes they will give you X and say you should find KSP. Now they can add another sort. If they add another sort like NaCl, NaCl is very soluble. So when they add it to this guy, then that means that you will have excess of chlorine. So that excess chlorine must be added to this guy before you do anything. Because the chlorine you get from here is different from the chlorine you will get from here. But you know, from chemical equilibrium, when you add this now, there will be more chlorine. That means equilibrium will shift to this side and you produce more of this guy. So those that understand chemical equilibrium. But let's look at this question. Or let me do another one. If you have PbCl2, what would this one give us? Pb2 plus 2Cl minus, Abi. That means if this is X, what would this one be? X, Abi. What would this one be? 2X. Do you get that? And they have their units. Then KSP for this is going to be X mole per dmq into 2X mole per dmq. Sorry, I'm writing it to this one. Then you raise it to the power at the front. Raise to the power of 2. Anytime you have that power at the front, you will raise it to the power. Shall you get? You raise it. So then we are going to now have that KSP is going to be X, let's open the bracket. This is going to be X mole per dmq into 4X squared, Abi, mole square, dm minus 6. Do you agree? Breaking it down further, we have KSP equals 4x cubed, Abi, mole times mole square, mole cube, dm minus 3 times dm minus 6. Is that taken? So that's it. So if you are given a sort like this is the formula. It's not like you will cram it, so you are the one that will work your way out. That's just what it is. But let's take a question so you understand what it is. And the unit is a mole per dmq. So that's why you have to be careful. So let's solve this one. You will see how to solve this. The solubility of calcium fluoride at 37 degrees Celsius. I still have many things to teach you in inorganic. So when I'm through with this now, I'll quickly teach you that one. Continue with that. So when I see question on common ion effects, then I will explain it better. The solubility of calcium fluoride. Calcium fluoride. What's the formula for calcium fluoride? CaF2. So you already know it's going to look like this guy. The solubility of calcium fluoride at 37 degrees Celsius. at 37 degrees Celsius is 3.9 gram per dm cube. At 37 degrees Celsius is 3.9 gram per dm cube. Is 3.9 gram per dm cube, full stop. What is the solubility product of the salts? What is the solubility product of the salts at this temperature? When you get to hostel, make sure it's book. Just be reading every time. Question mark. What is the solubility product of the salt? So which one are they asking? Is it KSP or X? KSP. Of the salt at this temperature? Question mark. Ca equals 40. Ca equals 40. F equals 19 gram per mole. Ca equals 40. F equals 19 gram per mole. Now, if you look at what they gave you here, they gave you the solubility in gram per dm cube. But if you remember our formula, solubility is always that you have conc in gram per dm cube is equal to mass over volume times 1000. Do you remember this formula? Conc in gram per dm cube is equal to mass over volume times 1000. And conc in mole per dm cube is equal to conc in gram per dm cube over what? Over molar mass. Abi? Now, look at this, my calculations. My units are in what? Mole per dm cube. Abi? Can you see? But look at what you are given in your question. They gave you the units in what? They said calculate KSP, but they gave you the units in gram per dm cube. If you are given in mole per dm cube, you will just split it and do it. I'll do it for you. But which means that what they want you to do first is convert the gram per dm cube to mole per dm cube. So after you got mole per dm cube, then you can now look for KSP. So how do we do this? You already know the formula B. So how do we calculate molar mass for CaF2? That's 1 Ca plus 2F. Abi? 1 Ca, what's the Ca? 40 plus 2 into fluorine is what? 19. So what would that give us in total? 78 gram per mole, if that's the molar mass. So that's the molar mass now, Abi. 78 gram per mole. Molar mass of CaF2. 78 gram. So now that we know molar mass and we know conc in gram per dm,